In this video, I'll talk about combined series parallel configuration and high and low level redundancy. I'll probably make videos for the other two. So here is a combined series in parallel form. We have R1 and component 1 and 2 that are in parallel. They form a series with 3, 4, and 5 are in parallel form, are in series, and then the whole thing is the system. So we're going to designate A to be outcome for 1 and 2, B to be the outcome for A and 3, and work it accordingly. So for A, we have the failure for 1, and we have failure for 2, and if we multiply it and subtract from 1, we have the reliability for A. For B, we have the subcomponent A, which is in series with 3. So we need reliability of A times reliability of 3, and we found reliability of A up there. For C, strict application of the multiplication rule, probabilities 4 times 5, reliability of 4 times 5. So now we have B computed and C computed, and they are both they're in parallel form with each other, but then they're in a series with 6. So we have failure for B, failure for C. This is reliability um, for the first component, and then this is reliability of 6, and if we multiply, we get the system reliability. We introduce redundant components so that we can increase the reliability of the system. Of course, by doing so, we introduce cost and maybe weight and time and a lot of unfavorable outcomes, but generally the result is a higher reliable system. This we call high level redundancy. Notice we have two A components and two B components, but one A and B are in series and one A and B are in another series, higher and lower series, and then combined they form the system. So to compute, and in these examples we are assuming equal reliability. So we have 1 minus r squared here as the failure for the top series, because A and B are both equal in their reliability. So the failure would be, we can just square that. And then if we square that again, we get the failure for both series, and then we subtract it from 1. So in this fashion, if we were to work through the whole thing, we can reduce this to this form that you see here, and we will use that in a minute later. Here is a low-level redundancy. Notice we still have two A's, but now they're working in parallel, and the two B's are in parallel, and then they form a series together. So again, assuming equal reliability, we've compute the reliability of the first of A's, which is the failure squared minus 1, and then because we have two A's, and then we square that because we have two parallel two parallels in a series. And so this will be the reduced form here. So comparing the low-level redundancy and high-level redundancy and seeing which one has a better reliability, if we subtract from the low the reliability of the high system and go through it, we'll end up with this right here, and it is greater than 0. So a high level redundant system has a lower reliability than a low redundant system. Okay, I think I will come to this uh, to the rest of it in another video.